Alright, this is the question I'll be doing for my exam 3 CPR. And it says that the figure shows magnetic material uniformly magnetized with M equals M A hat X, where magnetization M is in units of amp per meter. The material has a rectangular shape and two closed surfaces, dashed labeled 1 and 2, and have intersections with different regions of the material. The cross-sectional area of the material is 2 meters squared, and its length is in the A hat X direction is 2 meters. And it says that note that integrating the field H over the surface is not physically meaningful, but we will neglect the fact of this problem. And for part A here, it says that if the surface integral over surface 1 is given by h dot ds equals 4 amps per meter, what is the magnitude of the magnetization M? And we know that the magnetic flux intensity is mu naught times the field intensity plus the magnetization. So then we can distribute this mu naught to both variables. And then we can say that mu naught, the integral of h dot ds, is equal to negative mu naught, the integral of magnetization dot ds. And we know that h dot ds is 4 amp meters, as given right here. So then we know, once we integrate over this, we were actually given the surface area at the top of the problem. So then we can plug in that value right here. And then whenever you divide it over, the 4 amp meters over 2 meters squared becomes negative 2 amps per meter in the A hat X direction. Next, we have to compute the value of the second h dot ds over the closed surface 2, which is this one right here. And for this one, we can do the same thing where we do h dot ds is equal to negative m dot ds. And when you multiply by mu naught, you see that this h dot ds becomes b dot ds. And we know that for any closed surface, b dot ds will always be 0. And what this means is that if we have a surface and it has a flux intensity or field intensity going into it, and our integration has enclosed this, it means that the electric field going through it will go in and it'll wrap back around and come out as well, so that the total over the area, these two, will cancel out with each other, so that the total is 0.